All right. One of the requests I got was to do a Taylor series from 2008. So I have the problem, everything done here, all the answers are here, so I can not have to use a calculator. You guys should, I sent you guys the answers. You should be looking at that as we're doing this, okay? They give you a chart of what's going on with 1, 2, and 3. So I reproduced the chart and I'm only showing you 2 because they only asked about 2. The 1 and 3 were just extra information. They wanted to, throw some extraneous information at you. So let's look what the chart was saying. So when x is 2, h of x, the y value is 80. The first derivative, slope, if we need it to be 128. The second derivative, the third, and the fourth derivative, some ugly fractions there. Okay, so with this much data, we can write a fourth degree Taylor polynomial up to a fourth degree if we want to with this data. We just put those as our coefficient. Let's see what they ask us to do. A says, write the first degree, just the first degree, and use it to approximate 1.9, as we like to do. So, I would call that P1. Remember, Taylor polynomial, since this is a first degree, we'll do 1. So remember, that's going to be 80. Remember, you do the regular function plus, then it's going to be 128. X minus 2. Remember, we always do x minus the center. This is at 2, they said. And it's to the first power over 1 factorial. Now, those ones were unnecessary, turns out, but that's P1. They asked us to use it to approximate 1.9. So I plug in 1.9, and I get 67.2. So I get 67.2. So all right, that's my approximation for 1. Well, they asked me, is it greater than or less than the actual h of 1.9? Is our approximation more or less than the actual normal value? Well, I highlighted, if you look at your notes, it's always increasing. So we're going to be actually coming from the bottom side with our approximations trying to get up to the value. So we're going to actually be less than. So our value, I know we'll call it our P1 of 1.9 is actually less than the actual value. And you can just say, just because it's increasing, they just say because h prime is increasing. Okay. All right. So that's the reason for A. B said, write a third degree Taylor and use it to approximate 1.9. So a third degree, you got your 80, your 128, that's the first degree. The third degree is you keep going. So we got 488 thirds times x minus 2 squared over 2 factorial. Remember, it's just going to be x minus the center squared to the 2 factorial. Then we got 448 over 3. And we also have the 3 factorial. So I only have to do those. They left that one off. We could have gotten a fourth degree, but they asked for a third degree. And usually that means Lagrange is coming. Okay, we'll talk about that. And here's what they said. Use it to approximate 1.9. And we get 67.988. So again, we're getting a little bit more accurate. We're on our way up to the actual value of 1.9. You can see we grew from 6.7, so we're under approximating a little bit, but we're still below it. So, but we're more accurate because we've had more terms. All right. So to find that, you would plug 1.9 in everywhere. Right. We did that a lot in class. All right. So that was interesting. That's all we've had to do so far. Now they took Lagrange off the test. So, but I want you to just learn Lagrange error. It says use Lagrange about 2 to approximate 1.9. Show that the error is less than 3 times 10 to the negative 4. So that you're really close. Well, remember for our error, we would do this. I'm just going to erase that part. We said the actual error is the difference between, it doesn't matter which order you write this in, they wrote h of 1.9 in comparison with P3 of 1.9. So we want to know how accurate our third degree is. So remember, the error is the difference between the actual and R's, right? So R's was P3 and H of is the actual value. All right, so the difference, remember, has to be less than or equal to. And if you remember for Lagrange, it's the maximum the derivative can be. Well, of the next term. So if we have a third, it has to be 4. It has to add 1. So 4 is 584 over 9. All right, and so that's the maximum because it's increasing, and that's what's happening at 2, so it's up to that. And then we do times the actual, it's the next term, which is the 4th term. I'm just going to 1.9 minus 2. If you guys remember, we're just plugging into what the next term would have been. The next term would have been, I erased this, but the next term would have been 584 ninths x minus 2 to the 4th over 4. All right, 4 factorial. So we're just plugging in 1.9 into that. That's pretty much what you're doing. You're plugging into the next term. Okay, and you calculate this. Use your calculator. I think I got 2.707 04, and then times 10 to the negative 4. All right, so that's how close I am. That's my error, and it said show it's less than 0.03 times 10 to the negative 4. So I'm 0.0027, and that is definitely closer than 0.0003. Okay, so but they said show that value. So what was it, 2.7? Yeah. So yeah, this one's actually 0.0002. Sorry, and then the other one was 0.003. So definitely less than. All right, that's it. So we just had to show that. That's Lagrange. They took this off the test. So really, this one was just practicing writing a couple Taylor series for us, and then we had to find what the error was.